This video demonstrates the generic Simulation Solutions flash drum simulator. This simulator includes two DCS schematics as well as a 3D virtual reality interactive outside operator. Like all Simulation Solutions simulators, the DCS schematics and outside operator are two-way communicable, and any move made on the DCS will also be seen on the outside operator, and of course vice versa. A flash drum is a separation vessel primarily used to separate components that have a large difference in their volatility or boiling points. Flash drums can also be called knockout drums for their ability to knock out more volatile components before a stream enters a larger distillation column. In this particular case, a binary liquid stream of hexane, C6, and butane, C4, enter the low-pressure vessel, which allows the more volatile component, butane, to flash or vaporize and leave the system as a gas. The less volatile or heavier component, hexane, will leave the system from the bottom of the drum as a liquid. This flash drum unit has a feed controller which allows 70 gallons per minute of the hydrocarbon feed to enter the unit at design conditions. Trainees can control both the flow of this inlet feed as well as the temperature with a second controller which varies temperature with a hot oil heat exchanger. A pressure controller at the top of the drum controls how much pressure and overhead vapors the flash drum will produce, while a level controller on the drum controls how much flow leaves the system as liquid at the bottom of the vessel. With these four controllers, students can alter separation, vapor to liquid splits, and the overall amount of material that enters the system. In the second schematic, you'll see that the previous four controllers on the system can still be operated. However, what is new about this schematic is that there are three boxes showing the component mass balances for the feed, overhead vapor, and bottoms liquid streams. While Analyt Indicator 420 and Analyt Indicator 410 show the purity of both streams exiting the system, these three boxes give more insight into the exact component makeup of these flows. Trainees are able to quickly calculate mass balances on both a butane and hexane bases, as well as see how changing temperature and pressure changes separation. This breakdown also clears up some trickier points regarding separation. For example, a change in pressure has the potential to worsen purity in both the overhead and bottom streams. So now I will provide an example as I will change the pressure of the system, and we will see how the overall components splits change for the system. So if I adjust the output from 15.1% to 18%, we will see that initially there is a hit by the pressure and the flow will also begin to decline. For FI420, we will see that the splits change as well. So you have butane now at 0.87 pounds per second, you have hexane at 0.24 pounds per second, different from the original 0.78 and 0.22, which they are at design conditions. The bottoms components also are altered, as well as the temperature of the bottoms. So now I'll put this back into design conditions, and we will head to the virtual reality outside operator. This interactive 3D virtual reality outside operator contains all of the equipment that was shown on the DCS and is fully operable by the trainee. You will also note that there are various bypass block valves that trainees may need to utilize in case there is a fault with the main block valve on the line. Trainees are given an opportunity to fully explore the outside operator as well as the DCS schematics in order to familiarize themselves with the program before training exercises begin. So now we will go a little bit into the virtual reality outside operator. So now we will go into here. We will see that there are various valves to operate. This is a hand valve. You can open and close it, and it will adjust both the system and the outside operator view as long as the system is running. For this demonstration, I will show one of these valves changing. So if I close this valve, you will notice that there will be an alarm going off. This will indicate that there is an issue with the system. So if I close this, you hear an alarm. I will silence it and put this back into design conditions. So now that we're back in design conditions, we can see that any change to the virtual reality outside operator will be demonstrated on the DCS screen, and if there is any issue with the system, such as an alarm, this will be indicated by the beeping sound. This will occur for any other valve used in the system and for any other aspect of the virtual reality outside operator. For more information on the FlashDrum simulator or any other Simulation Solutions products, please call 732-389-5400 or go online to www.simulationsolutions.com.